All right, what we're going to be looking at in 3-2 are the theorems that relate to angles created by parallel lines. Now, I want to make an emphasis of that again, as we talked about in class. Everything we're going to talk about as far as postulates and theorems go require these lines to be parallel. I've got two parallel lines here. I'm going to cut them by a transversal. As you recall, we talked about the idea that parallel lines are known to be parallel because they're marked with these single arrowheads. So remember, these arrowheads, that's a not so great arrowhead there. Oh, there we go, that's a little better. Are a way of indicating that lines are parallel to each other. So if I were again to label these, let's call this line L, this line M, this line P, I could say that L is parallel to M. Now that's going to set up everything we're going to do from here on out. If the lines are not parallel, none of these rules apply. Be very careful because as we move through the unit, the bulk of our practice now will be on lines that are parallel. However, that doesn't mean that that's all we're ever going to see between now and the end of the unit. Keep these things in mind as we work. Now, we're going to have a series of theorems which you've already worked on as far as discovering the primary principles. We're just going to put some names on them now. So for example, this angle right here, let's call it angle 1. And this angle right here, we'll call it angle 2, are corresponding angles. Now, as you discovered during the exploration today, corresponding angles are going to be congruent. That was one of the consequences that should have come out of your exploration today. Now, that comes also as part of what is referred to as the corresponding angles postulate. Now, I often add on to this the statement that it's really a theorem. I can prove using the parallel postulate that this is going to be true. The problem is the proof is very complicated. It's not really intended for an introductory geometry class. Since the book doesn't hold you accountable for writing the proof of that, neither will I, and we call it a postulate. Now, another comment about all the theorems and postulates we're going to cover. They can be written in the form of if-then statements. Conditional statements, where we started our unit off. So let's add the words if and then onto our statements so far. So the corresponding angles postulate says if I have parallel lines, so I want to say if line L and M are parallel, then this consequence follows. And that's where we're ultimately headed with this. If I have parallel lines, what consequences are going to come from that? The corresponding angles postulate says that angles 1 and 2 are thus going to be congruent. What would this look like in a problem? Just to give a quick context to it. Well, let's take a couple of parallel lines. So there are two parallel lines. We'll cut them with a transversal. And maybe I know that this angle over here is x plus 40. I also know this angle down here is going to be 100. And the question is, what's x? Since these labels are pushed into corresponding angles, and I've already said these lines are parallel, I can conclude that x plus 40 must equal 100. Therefore, algebra happens, and I can see that x must be 60. We're going to be doing a lot of algebra with these problems, so make sure your algebra skills are up to speed, and if not, we're going to spend some more time practicing that. Make sure that you help bring this information to me so we can work on these things. But I'm going to kind of assume you know subtract 40 from both sides. Again, the idea behind this is to use that corresponding angles postulate to establish that these guys are going to be congruent given that these lines are parallel. Parallel lines leads to the conclusion that corresponding angles are congruent by the corresponding angles postulate. Now there's a whole slew of theorems that follow. They all start on the same place that the first theorem we talked about started on. So let's go ahead. We're going to copy this in here. Maybe we're not. I'm going to try to copy it real quick here. Duplicate. And we're going to do another one of those. So let's see. There we go. Duplicate. Unfortunate. All right, so let's go to this one. We're not going to talk about the corresponding angles postulate this time, though. So let's get rid of that. And we're not going to talk about these angles. We're still going to start off, though, with the idea that L and M are parallel. Now the issue becomes, what about these angles? Let's call this angle 2, and let's call this angle 3. In this case, I can say that the alternate interior angles are congruent. Now, this theorem is referred to as the alternate interior angles theorem. For the sake of speed, I'm going to abbreviate that as AIA theorem. Be careful how much you abbreviate as we practice, because what you'll find is very quickly you forget what all the abbreviations mean. But for now, I'll write that down, because I also have it on the page that the AIA is referring to alternate interior angles. And that would be angles 2 and 3 are congruent. Again, we're going to use this very similarly to the same way we did it in the previous problem using the corresponding angles postulate. Now there's another theorem. I'll stay on the same slide. Let's grab a different color marker. And let's talk about these angles out here. How about angle 1? And let's take this angle down here. We'll call it angle 4. Nope, I want this angle over here. We'll call it angle 4. We will ignore this one. There we go. This one says that if the two lines are parallel, so if L is parallel, hey, come here you, to M, then, now this time we're not talking about alternate interior angles. We're going to talk about alternate exterior angles. And we would say they are congruent. Alternate exterior angles are congrats. Wink. Let's rewrite congruent. I did kind of get ahead of things there. There we go. So we'll put you right there, and we'll get rid of that. There. So far we have theorems that say alternate interior, alternate exterior are congruent. Now this one, same name as the last one. It's the alternate exterior angles theorem. So alternate exterior angles theorem. And honestly, as you're starting off, I probably would not abbreviate much more than that until you're really confident about remembering what all of these abbreviations mean, because that's where you're going to find yourself in trouble. So the alternate exterior angle theorem says that the alternate exterior angles are going to be congruent. And again, I can use this as a one-step problem. Now note, both of these are theorems. You will be expected to be able to prove them. Postulates, we don't prove. We use postulates to prove other theorems. So what I want you to start doing is thinking about how you might use the corresponding angles postulate to prove this one. Something else to think about. 1 and 5 are corresponding. is there any rule that would map 5 and 4 as congruent, which would then let us say that 1 is congruent to 4? So start to think about those kinds of things. Lastly, in this collection of theorems of consequences that come from parallel lines is the same side interior angle theorem. So again, two lines that are parallel. I'm going to cut them by a transversal. There's my transversal. My interior ear angles, the same side interior angles, might be 2 and 3. These guys. Those angles are not congruent. You should have discovered that as part of our exploration. What you should have also found is that they are going to be supplementary, that they're going to create a line together. So that if this angle up here were, say, 40 degrees, this one would have to be 140 degrees. Now, if you don't believe me, go back to your exploration and take a look for yourself. Fold up the paper, tuck it up here into this angle, and then compare it down here to see if it creates a line with the second paired angle. This is called the same side, oops, didn't switch pens over on me. The same side interior angles theorem. And what it says, like the other ones, if I start off with two lines that are parallel, then it follows that I have same side interior angles that are supplementary. So, most of these rules are related to angles that are congruent. These, on the other hand, refer to angles that are supplementary. So corresponding, congruent. Alternate interior, congruent. Alternate exterior, congruent. Supplementary goes with same side interior angles. All those S's get paired together. And lastly, these only apply when the lines are parallel. They're all consequences of parallel. If you think about how we used to map our proofs when we first started, we went from idea to idea to idea. So if I were to introduce the idea that I have parallel lines, so L is parallel to M, what consequences come out of that? And then what rule tells you that? And you should actually be able to draw a series of outcomes that we've talked about this afternoon. All right, when you come in here tomorrow, we're going to start looking at some problems that use these rules. See you then.